8.2. Now, I had asked you guys to compute various combinations. Did anyone do that? You did? I'll want the numbers soon, but not yet. Thanks. Okay, so section 8.2. Today we're just going to do some more basic type questions. In section 8.2, we'll get a little more interesting and a little deeper on Monday. Okay? So, let me ask you a question, and it might seem totally unrelated, but I assure you it's not. Okay? How do we find the average or mean of a data set? So, I mean, suppose you took 5 tests in a class, and you want to know, what's my average? How would you guys do it? Yep, absolutely. In the case of 5 tests, you would add your 5 scores together and then divide by 5. In general, what you would do is you would add all the data points, and then when you divide by the number of data points, if you want to write that out like this, you could say you're adding up all n of your data points, and then you divide by n. If you don't like symbols and notation, don't look at the bottom line. Okay? You guys with me there? All right then. What we are going to want to do is the following. Given a probability distribution table, what we are going to want to find is the average. How would we find it? And I'm going to put average in quotes. The reason why I put that average in quotes is when you're given a probability distribution table, if you want to find the average value, it's called your expected value. So, there is a formula that we're going to come to here that helps us compute our expected value. And it's actually a very easy formula to use once you have it. Of course, you will always be given formulas on your tests and your quizzes. But what I would like to do is put up an example of a table, and let's kind of use our intuition to come to the formula ourselves. Doesn't that sound exciting? I hope it totally sounds cute. Man, I hope you guys are more exciting tonight than you are. Ever in this class. All right, so I am not. I'm in bed by 8 o'clock on Friday night, so I'm just chilling. All righty, so I'm going to make up a silly little problem here, and we're going to play with it, and we're going to use our knowledge of finding averages, and lo and behold, we're going to come up with a formula. Now, I do want you to write down the table, but you don't have to write some of the intermediary steps. It's really just important to me that you follow along with what we're doing, and we'll come to this formula together. It's pretty cool. All right? So, suppose we're in a scenario where we queried a bunch of families, and we wanted to know the number of hours of television that they watched per day. And say it's over like a month period. So we'll get how much TV they watched over that month per day, and then find that kind of average for each family. And suppose we come up with this table. Here's the number of hours and then we'll talk about the frequency. And this is a totally made up problem, so don't ask me where I'm getting these numbers from. Well, you can, I'll just say it's from my head. So, let me fill this in, and then let me explain this table to you. All right. What this says is the following. 7 families, see frequency, this tells us how many families on average watch no TV per day. 12 families on average watch 1 hour of TV per day. 4 families on average watch 2 hours of TV per day. 3 families watch 3 hours of TV per day. And 4 families watch 4 hours of television per day. Okay, are there any questions on this table? Because it's important to be able to read this. Okay, let me ask you a question. How many families did we query? Is there a way we can figure it out? There is. What would we do? We would add up all the frequencies. Do you agree that there's 30 families total? Okay, just add up of these frequencies, and I claim that we've looked at 30 families. All right, then. Now, let me add another line to this table. And this line is the probability. We're going to be talking about probability distribution tables. And when you're given the frequency, it's really important to know how to get from there to your probability. All right. Now, remember, when you're finding the probability of an event, you take the number of ways that can happen, or the number of ways it does happen, divided by the total number that you're looking at. So, let us put ourselves in the position to ask ourselves, suppose one of these 30 families was selected at random. What is the probability that they watched no TV per day? Well, how many families did watch no TV per day? 7 out of the total 30 families. Okay, what is the probability that a randomly selected family watched 1 hour of TV per day? Wouldn't you say it's 12 over 30? The number of ways that happens divided by the total. How about my next column? That would be 4 over 30, then 3 over 30, and then again 4 over 30. Are there any questions how I got that? All right, you always take, when you're given the frequency, you take that frequency over the total number. All right? Now, what do you get when you add up all the probabilities? You get 30 over 30, which is 1. It's exactly what you would expect. No pun intended. All right, so what if now I wanted to ask the question, and I wanted to say, okay, looking at this group of 30 families, let me write it this way. How many hours of TV per day would you expect to have been watched? Been viewed, I guess, is a little better. In other words, on average, how many hours per day did these people watch? Okay? Now, what I'm going to do is I'm going to use the idea of how to find the average. Remember, when you find the average, at least from our knowledge right now, don't you add up all of our data points and then divide by the total number of them? Okay? So, for example, if I was to actually write this out in a very painful manner, I would say 0 plus 0 plus 0 plus 0 7 times. And then I would add 1 to itself 12 times, 2 to itself 4 times, etc. But you guys, isn't repeated addition by definition multiplication? Yeah. Okay? So if you don't want to write this down at this point, you don't have to. Let's watch. So, of course, if you want to, go for it. Do you guys agree? 0 hours were watched 7 times. 1 hour was watched 12 times. 2 hours was watched 4 times. 3 hours was watched 3 times. And 4 hours was watched 4 times. And what would we divide that by? 30. Now, these middle steps that I'm doing here, you might wonder why I'm doing them. But again, I'm motivating a formula. Once we have this formula, yeah, you can just plug in the values and use it. But I want to show you that it comes very naturally from what we know. Okay, so the first thing I'm going to do, which may seem backwards, is the following. Do you guys agree I can write this as 5 separate fractions? Okay. Normally, yes, we find a common denominator and put it over 1, but let's break them up instead. Do you guys agree I can write this as 0 times 7 over 30, plus 1 times 12 over 30, plus 2 times 4 over 30, plus 3 times 3 over 30, plus 4 times 4 over 30? Again, you might wonder why. Hold your horses. Guys, with me this far. Now I'm going to write it even differently. You know what I'm going to do? I'm going to say this first term is 0 times 7 over 30. And my next term, I'm going to say, well, that's 1 times 12 over 30. My next term, 2 times 4 over 30. Do you guys agree that this is legal to do? Because when you multiply two fractions, you're just multiplying your numerators and multiplying the denominators, and by default, the denominators on all these whole numbers is 1. So I'm going to continue down that line, and we are about to see something so cool. Okay? Are there any questions about how I've done what I've done? All right, so check it out. You guys, I have 0 times 7 over 30. And then I have 1 times 12 over 30. Then notice I have 2 times 4 over 30. My next term is 3 times 3 over 30. And then 4 times 4 over 30. Do you guys see how I'm multiplying each x value by his corresponding probability and adding that up? Isn't that what we're doing here? We take each x value, we multiply them by his corresponding probability and add them up. And that is actually the formula for expected value. First off, if anyone really cares, the answer to this I think is about 1.5 hours. I don't know if you really care about the answer, but I'm going to write out the formula, and then I'm going to look at this. So the formula for your expected value, we write that as E of x. What you do is you take your first x value and multiply him by his corresponding probability. Then you take the next x value, multiply him by his corresponding probability, and do that throughout your whole table. Let me write that out in English just so that you guys have it in your notes. Take each x value, multiply it by its corresponding probability, and then add them up. So do you see how this formula formula came from just our knowledge of finding averages, that's kind of cool. All right, don't worry if this formula looks funky to you. We are going to be going through a ton of examples. You guys will be down with it soon enough. All right? Now, let me say something to you guys. Okay? I always am in favor of, before I do any computations, kind of looking at my data and figuring out in my head around what the answer should be. At least some range of it. The reason why is I am prone to sometimes push the wrong button in my calculator, and I always want to check if my answer makes sense. Okay? So, let's look at our probabilities here, you guys. Okay? Both things come into account when you find your expected values. These x values matter, and so do the probabilities. Would you guys grant me that the highest probability is right here in this table? Right? 12 over 30. And 7 is pretty strong, isn't it? Okay, that's our next highest probability. But then, over to the right of 1, don't we have a total of 11 over 30 over here? So, while this is the strongest probability, don't you agree that probably the average number of hours is at least going to be around 1, but it's going to be pushed a little more to my right because these probabilities add up to be something higher? And look at what our expected value was. So, in the back of my head, I say, yeah, my answer makes sense. Aren't you thrilled? All right, so let's practice using this formula now for a bunch of questions. I'm going to do one question out of the book, and then what I'm going to do is I'm going to go back to those really interesting probability distribution tables that we came up with last time. Remember we were talking about drawing green and purple balls out of the bag, and we also talked about apples in a barrel. Remember how I asked you guys to compute what those probabilities were? Well, we're going to find the expected value of each of them. I mean, if we were going to do those computations, we might as well take them a little bit further. Now, what I am going to say is we're going to get a little more interesting next time, and we're going to talk about, for example, making investments and expected returns. We're going to talk about lotteries and all sorts of things. Okay? So by no means am I finishing this section today. We're just getting it going. The first problem I'm going to look at, if you have your book, fine. If you don't, I'll write out all of the relevant information. I'm going to do number 10 in section 8.2. And this is called expected demand for magazines. It says the owner of a newsstand in a college community estimates the weekly demand for a certain magazine as follows. And here's our table. So here's the quantity demanded, such a strong word, and the corresponding probability. And the table that's given is as follows. I thought I was going to run out of room. So, for example, for this magazine, there's a probability of 0.05 that 10 copies of this magazine will be demanded. Okay? The probability is 0.15 that 11 copies will be demanded. We have 0.25 here, 0.3, 0.2, and again 0.05. This table was given. When you're given your probabilities, you don't have to do that extra step that we just did when we were only just given the frequencies. All right, now, what we want to do here is, what I shut my book and I should not have, is the way the problem is worded is they ask us a newsstand owner can expect to sell per week. Now, I will grant you normally you would, the way that they would do this is first they would take the frequencies and then compute the probabilities. Okay? But this is a very reasonable question for a newsstand owner to ask, because you don't want to buy more than you're going to sell, otherwise you're going to take a loss. Okay? Now, the biggest hint that you are going to use your expected value formula is right here. When you see the word expect, you pretty much know that you're going to be computing the expected value. Okay? Now, before we compute our expected value, let us first look at the probabilities and ask ourselves about where should we lie. Okay? Do you guys agree that my highest probability is right here at 0.3? Okay? But this is pretty close following, isn't it? And 0.15 is also pretty strong. These guys kind of don't make too much of a difference. But do you guys agree that our answer should be around 12 or 13? Okay? Now, just like when you compute your average grade in a class, okay, very often you don't get one of your actual exam scores. You usually get some decimal. Well, we can expect the same thing to happen here. Alrighty? So, how would we compute our expected value using our formula? Well, literally, you guys, what you do is you take each x value. So first we'll take 10. And multiply him by his corresponding probability. So we have 10 times 0.05 plus 11 times 0.15 plus 12 times 0.25 plus 13 times 0.3 plus 14 times 0.2 plus 15 times 0.05. Do you see how we use this formula? Literally, it's this times this, plus this times this, plus this times this, all the way down the line. All right. Has anyone computed it? You should, I believe, someone computed, but I think you get about 12.6 here. Anyone have it? And isn't that about what we expected? Did you get 12.6? Okay, I'll just do this. 10 times 0.05 plus 11 times 0.15 plus 12 times 0.25 plus 13 times 0.3 plus 14 times 0.2 plus 15 times 0.05. Yeah, 12.6 is that. Probably too much. All right. You guys okay? Cool. So let's just go back to one of our examples from class on Wednesday. How about we had 2 balls were drawn from a bag. Remember this? If you were here. Containing what? We had 4 purple balls. And what were the other colors? Oh, how perfect. And 2 green. And we wanted to count, well, the number of green balls was counted. And you may or may not recall, but we set up the following table. First off, how did we do these computations? Okay, good. First we had to figure out how many green balls could appear? Well, we only picked 2 balls, so it could be 0, 1, or 2. And how did we compute the probabilities? Combinations! Right? Didn't we have 6 choose 2 in all of our denominators? And what did we have up here? Well, we had 2 green balls. We wanted none of them. So we had 2 choose 0 times 4 choose 2. And then our second term was 2 choose 1 times 4 choose 1. And then it was 2 choose 2 times 4 choose 2. Or 4 choose 0. Neat. Remember this? All right. Well, what if after we had this, I asked you to find the expected number of green balls picked? Okay, well, this is when I asked you guys to actually go through and do these computations. I know it's a pain, but that's okay. So, let us do this first guy. What did you get for all of your denominators? 15, good. Now, if you put these in decimal form, totally fine. I don't care whether you have these things in fraction form or decimal form. I really don't, okay? I claim, and I want to show you guys a little trick right here. You're going to get 1 over 15 here, and you should get 8 over 15 here, okay? I'm going to show you this next one, but just hold on, okay? What I'm doing is I'm teaching you great strategies for being as lazy as possible, yeah? You were looking at the number of purple balls being counted when you computed that. You're exactly right there. Okay? Suppose you just computed these guys and you're like, oh my God, I hate computing combinations on my calculator. Do you have to compute this as a combination? Or is there some other way you could figure out what it is by what we have? Okay, I'll even answer my own question. Yes, there totally is a way to figure out what it is. What do all my probabilities have to add up to? 1. Haven't we accounted for 9/15? So couldn't you take 1 minus 9/15 and say, oh, that's got to be 6/15? I'm just trying to teach you really great techniques of being lazy in the math class. No, it's a good habit. All right, you guys with me this far? Okay, well, now let's find the expected number of green balls selected. But before we do our actual computation, what I'm going to do is look at my probabilities. Where's my probability the highest? Right here at 8/15, isn't it? Picking 1 green ball. But isn't 6/15 a lot bigger than 1/15, relatively speaking? Yeah. So don't you agree that we should expect our probability, don't you agree that we should expect the number of green balls to be between 0 and 1, probably closer to 1? Okay? You don't have to do that step, but I always encourage people to do that. So what do we have? To find our expected value, you take each x value times its corresponding probability. Alrighty then. If you do this, always be excited to have a 0. Multiplication by 0 is a gift. So do you guys agree you have 8/15 plus 2/15, which is 10/15? And again, if you're a decimal type of person, do it. So you end up getting about 0.67. And isn't that exactly what we expected? Between 0 and 1, closer to 1. Using your intuition? It's not all, sometimes you have a very spread out table, but you could always at least look at where your highest probabilities are and know that your expected value is going to be right around there. Yes, absolutely. You guys okay?